Hello, this is Mr. Huff, and I want to do a second video for the AP Physics exam review. So I just did some quick sketches in my notebook, and we're going to talk about those because I left everything in school. So here's what you need to be thinking about. I have a bowling ball, and it's on top of a cliff, and I have it launched with some velocity. You may need to think about how long it takes this bowling ball to reach the ground. If you know the height, we also know that gravity is involved, so we're going to look at this equation. Y is equal to 1/2 at squared. So we rearrange that to solve for time, which is equal to the square root of 2 times the height divided by the acceleration due to gravity, and that tells us the time it takes for the ball to fall from this level until it hits the ground. If you're talking about a projectile or something bouncing, this time will tell you the time from the highest point to the ground, so you would need to double it to tell you the time that this was in the air if the bowling ball bounced. Okay. For the next couple of problems, you need to think about look at this slope. We have a mass with a smaller mass sitting on top of it, and it's being pulled up the incline with the force F. Why is the little mass not sliding off? Think about that. And if it's not sliding off, what would have to happen to make it slide off? All right. The other thing I want you to do is consider two masses, one being pushed along or pulled along a surface without friction, actually with some friction. I want you to compare the frictional force if it's horizontal versus if you're pulling it up an incline. Does this incline increase the frictional force or does it decrease the frictional force? Keep in mind that the force of friction is dependent on the normal force. So the block that's being pulled across a horizontal surface has a higher normal force than the one that is being pulled up the incline because we have a trig problem here. And if you think about that, let's take it to the maximum. If it was being pulled straight up and down, there would be no normal force. With no normal force, there's no friction. Okay, now I want you to consider a mass being pulled along a table. What happens to the force of friction if the mass is doubled? So if you think about the formula for the force of friction, it is the coefficient of friction times the normal force, which is the same as saying the coefficient of friction times mass times gravity. So if you doubled the mass, you would double the force of friction. This is number 18 in the homework, or in the assignment. What was that? Study guide. Okay. In this one, it talks about an elevator slowing to a stop as it goes up. So the velocity is going up. And the key to this problem is drawing the free body diagram, recognizing that the force of gravity pulling down is opposing the tension going up. It's slowing down as it goes up. So we expect to see a negative acceleration at this point because it's slowing down, depending on your point of view. I'm not going to try to keep up with the signs because it's going to be confusing. But look at this. The net force is the difference between the mass times the gravity and the tension. That needs to be a negative there. Gosh. Okay, so change that to a negative. So, and then my math is, okay, I don't know what I'm doing. Okay, 1,000 times 10 is 10,000, and that should be a subtraction. I went through and changed some signs, and I shouldn't have. Okay. So it should be 10,000 minus 8,000. Here's the result we need. The net force acting on the elevator is 2,000 newtons. So if we use 2,000 newtons and we use the net force divided by the mass to find the acceleration, we see that the acceleration is 2 meters per second squared. Please ignore the signs. And then I use the velocity squared equals the initial velocity squared minus 2ad. So you end up with this formula here where you have the velocity is equal to the square root of 2 times a times d. And if you do that, you get 9 times 4 and you get 36. So 36 squared, or square root of 36, is 6 meters per second. Okay, so the key is, let's go back and look at the only thing that makes sense in my example here. The difference between these two is telling you your force. Use that to find your acceleration. Once you have your acceleration, you can use this formula to find, using distance to calculate the initial velocity. We know the final velocity is 0. Alright, move on to the next one. This is number 20. It is a ball being held up by a horizontal rope and a rope at an angle. This horizontal rope does nothing to hold up the ball. The tension here has to hold up all of the weight, so that tells us that this component of this right triangle is going to be equal to the force of gravity here. So this is a trig problem to find this tension. Go trig. Number 19, we have a system. So we have 20 newtons being applied to 3 kilograms pressing against a 2 kilogram block. So the first thing is to find the acceleration of the entire system. So you take the force divided by the mass, 20 divided by 5, and we get an acceleration of 4 meters per second to the right. But the question wants to know the force of the 2 kilogram block against the 3 kilogram block. So Newton's law, third law, equal and opposite forces. So if the blocks are being pushed this way, the 2 kilogram block has to push back against the 3 kilogram block. So we would use the acceleration 4 and the mass 2, so we multiply those two together, we get 8 newtons, and that's going to be to the left. Alright, there's that one. Okay, let's try this problem one more time. I did it previously and messed it all up. So here we go. We have a little car. It's going 20 meters per second forward, and its mass is 200 kilograms. The coefficient of friction is 0.2. How do I know? I just made it up. I need to know the stopping distance of the car. To find that, we have to find the force of friction opposing the velocity. So force of friction is the coefficient of friction times the normal force. And we break that down into the coefficient of friction times mass times gravity. So 0.2 times 200 times 10. And we get a force of friction that is 400. That is opposing the velocity. So technically it would be a negative 400 newtons. We can use this to find the acceleration. So acceleration is the force acting on the car divided by the mass. So 400 divided by 200, and you get a negative 2 meters per second squared because it opposes that velocity. We can use this formula again to solve for distance. So distance is going to be equal to the initial velocity squared divided by 2 times the acceleration. 20 squared divided by 4 is going to give you 100 meters to stop. What if we tripled the mass of the car? Would that change the stopping distance? Let's take a look. What does the math say? So to find our force of friction, we do the same thing. The coefficient of friction times mass times gravity. And that gives us 0.2 times 600, which is triple the mass, times 10. We have a force of friction of 1200 newtons. Seems like it would stop a lot more quickly, doesn't it? But if you run that on out to see what the acceleration is, it's still exactly the same. If you start with 1200 newtons, divide by 600, which is a new mass, you still get an acceleration of 2 meters per second squared. The distance will be exactly the same even though we tripled the mass of the car. The thing is that force of friction is determined by the normal force. So if you increase the normal force, you also increase the force of friction. If you decrease it, they go together. So it's not going to change the acceleration. The most effective way to change the acceleration would be to change the coefficient of friction. So that should be about all you need to prepare yourself for the exam you have. If you'll watch this video and the previous video, and if the problems are making sense to you, you should do very well on the exam. Good luck.